Okay, number one, we have a banner being created for a bake sale, and the banner must have this. The length must be less than 200 centimeters. Okay, so we have to create an inequality that says that. How do you say the length of a banner must be less than 200 centimeters? So I'm going to go like this. The length must be less than 200. L is less than 200. The perimeter must be 500 or less. Does anybody know how to do the perimeter of a rectangle? Do you know what perimeter means? All the way around. So if I had that, I would add up all the sides, and that's my perimeter. So does this make sense if I do 2L plus 2W? That's a perimeter for a rectangle. Okay, so the perimeter must be 500 or less. So 2L's plus 2W's must be what compared to 500? What would I put in there? It says 500 or less. Does that make sense for a symbol? 500, I could be equal to 500 or less. Okay, define your variables. So we used L to show our length, and we used a W to show our width. So that's what my letters are. Now, are there any restrictions? So is there anything restricting the length? Well, length will have to be a whole number, because I can't have a negative length. And the width will also have to be a whole number. I can't have a negative width. Okay, let's graph this system. So I'm going to put L and W kind of like that as my Y and my X. Okay, so the first one, that L has to be less than 200. All right, what do we want to do here? What do you want to go up by? 25, 50? I'm going up by 25s. Okay, so there's my scale. I put 1 is equal to 25. Okay, so here's what I do. So if I go L is my Y, Y is less than 200. Kind of this idea. I have to be, I'm just going to do that lightly because this is not correct yet, because I have to cap it off at all my whole number stuff yet. So that's what I'm kind of thinking. It has to be below that. Okay, here's how I'm going to graph this equation. Okay, I'm going to use a method called intercept methods. Okay, here's what you've done in grade 10. You used intercepts. So if I cover up the W, so let's pretend that W was 0. Let's pretend W was 0. What would the length have to be? 250? So the L-intercept is 250. So I'm going to put that on there. 250. Okay, now I'm going to do the other. So now I'm going to pretend the L is 0. So now the W equals 250. So I'm going to put those two dots. And now I can make a line. Once I have the two intercepts, I can make a line through them. Okay, what kind of line do we want to draw? Looking at this kind of line. Dashed, solid. So this one can be solid. Okay, and we have to be less than that line. So what works? Anything in this zone works. And I have to go back and make a correction of something I did now that I see it. I did this one wrong. Our length doesn't have to be a whole number, because you can do a length of 1.2. So we should write this. Our length has to be above 0, though, and our width has to be above 0. That would be what the restriction would be. Sorry about that. I was thinking above 0, but whole numbers don't work because then it doesn't mean I could have decimals, and I could have decimals. Okay, so anything in this region works. Okay, so give me a possible solution here. So this coordinate could be a solution. That could be a solution. So if we had a width of 100 and a length of 50, that's a solution. Can you get me another coordinate in there that would work? This would be a coordinate that would work. So that would be 50 width and a length of 150. Okay, any point that you can pick that's in that zone would work. Okay, Sarah collects shells on a beach vacation. She does not want any more than 300 shells together. She collects white and tanned colored shells. Okay, so she wants white and tanned colored shells. So I'm going to go with a W and a T. She wants no more. She does not want any more than 300 shells. So I'm going to write something. She does not want any more than 300 shells. So what am I going to do? The white shells plus the tan colored shells, altogether, those shells, she does not want any more than 300. Does that make sense? Because she does not want any more than 300, so she can be below or equal to 300. Okay, I have to read this one carefully. She wants to have no more than 4 white shells for every tan shell. Every tan shell. Does that one make sense if I write it like that? I had to read that carefully. She wants to have no more than 4 white shells for every tan shell. Okay, define your variables. So we used a W to be white, and we used a T to be tan. Okay, what do we know about how many white shells we could have? Is there any restrictions to white shells? Yep, those have to be whole numbers. You can't have 1.2 white shells. You can't have negative. And same with T, that has to be whole numbers. Okay, now graphing this system, I'm going to put T as my Y variable, and I'm picking that because of this statement, Y equals 4x, that's the idea, and W there. So I would like to somehow go on my axis that I need a 300 high. So, I don't know here. Can't do what we did last time. Let's go up by 50s. I went up by 50s, so 1 equals 50. That's my scale, 1 equals 50. Okay, we're going to graph the system. Okay, I'm going to use the intercept method. So here's that equation. I took this as an equation, not an inequality. Now, what if I made T 0? Then the W-intercept would be 300. What if I made W 0? Then the T-intercept would be 300. And it's a solid line. And we're going to want to be below that line. Okay, now this one, if you ever were to graph it in your calculator, if you were to graph this in your calculator, you could get some points. Okay, so let's let's do that. Okay, so what I did was 4x, and I changed my scale to kind of match my drawing. I went from -100 to 400, and I went up by 50s because we were going up by 50s. Okay, so that's that. And I'm going to trace something like 50. So 50 comma 200 would be a point. And 0, 0 is another point. So I'm going to draw a solid line through that. And we have to be less than that line. So now I have to be on that side of that line. Okay, so anything in this zone is going to work, but I have to remember that I can only take the whole numbers in that zone. So you can't have decimal answers, but what's a solution? So something like this would be a solution. 150 white shells and 100 tan shells. That would be an example of something that would work. Okay, you can pick a bunch of points in there, but that's an example of something that does. Okay, I'll pick one more to do today maybe, and then we'll do some tomorrow. Okay, let's try this one, a vending machine one. So the machine holds, oh, I think this word is supposed to be at most. The machine holds at most 100 drinks. At most, 3 bottles of water are sold for each bottle of juice. Okay, so we have, let's go defining our variables. We have water and juice. The machine holds at most 100 drinks. The most amount of drinks you could have is 100. So all the waters plus all the juice have to be less than or equal to 100, because that's at most 100 of them. At most, 3 bottles of water are sold for each juice. At most, so we have to be less than or equal to it, 3 bottles of water are sold for each bottle of juice. Okay, what are our restrictions? So think about having water bottles. The water bottles will have to be whole numbers. You can't have 1.2 water bottles. You can't have negative water bottles. Same with the J. So they have to be whole numbers. Okay, we're going to graph this. Okay, so I'm going to go, the 10 is the new 100. So my scale is 10. So I'm going up by tens. Okay, ready? I'm going to do the intercept method. So if I cover up the J, the W intercept is 100. Sorry, here I should make this J is the Y part and the W will have to be the X part. So the W needs to have an intercept at 100. And if I cover the W, the J has an intercept at 100. Okay, that line is solid. And I'm going to have to be less than that line. Okay, and if I graph y equals 3x, we could get a coordinate, so 0, 0. 0, 0 is on that graph. 20, 60. 20, 60. So 20, 60. So I found some points using my calculator. 20, 60. I could kind of understand that algebraically. If I put a 20 in, that's a 60. And we want to be less than that one. So any point in that zone will work. Write an objective function. So now an objective function is our money part of it. So each water sells for $1. So the revenue we get is $1 times the waters plus $1.25 per juice. What is the max revenue? Okay, so the most revenue is going to come from that point. So we're going to have to figure out that point. Okay, so we're going to let our calculator do that for us, but do you remember when we were doing this in our calculator, we couldn't do something like this because our calculator only does a y equals. So instead of a y equals, we're trying to get a j equals equation. So I'm going to move the w over. Here it's already good, right? We already could graph that one. Okay, so y equals, so there's my two equations, the 3x equation and then the negative x plus 100. Okay, I'm going to get this intersection point, so calculate intersection, enter, enter, enter. And there it is, 25, 75. So that's our intersection. So 25x, so 25w 75 juice. That is what's going to get us the largest revenue. So let's plug that in. $1 times 25 waters plus $1.25 for 75 juice makes 118.75.